So in this video, we're going to look at function composition, and just to get an intuition, just to get some kind of a high-level idea with what function composition is. Let's just define a function of one variable. Let's say f of x here equals to x squared, and let's have a function g of y equals to 2y. Now, if I were to define what is f of g of y equal to, what is this equal to? Well, g of y is 2y, so f of 2y is going to be equal to, I'm going to replace x with 2y, so this is going to be 2y square, and this gives you 4y squared. This is what basically function of f of 2y is. Likewise, if I like to do function composition of g of f of y, so what is g of f of y going to be equal to? So what is f of y? Well, f of y is y squared, so this is going to be g of y squared. And then what is g of y squared going to be equal to? Well, whenever I see y, I'm going to replace that with a y squared, so this is going to be equal to 2 and y squared, so that gives you 2y squared. Okay, so this is basically kind of a recap from math, from what function composition actually is. To define this a little bit more formally, if I have a function f, some function f that goes from a to b, and if I have some function g that goes basically in this case, so let's say g in this case goes from c to a. Okay, and now my question is, what is f of g of y going to be equal to? Okay, so g in this case is basically acting, because g is acting as this inner function here, and so I can think more generally. From a function composition perspective. Let's try to define the binary operator for function composition as a period. And what this period does basically consumes two functions. It consumes a function f and g. So the type for this period, more formally, is going to be defined as consuming this function. Let's say the first function consumes is this function f that goes from an a to a b, and then it consumes the second function. That goes from a c to a a. Okay, so you can think of this is first function over here is my function f, and you can think of the second function over here as my function g. And in turn, it gives you this new function. That goes basically from a c to a b. And this is basically what function composition actually is. It basically consumes these two functions to give you back a new function there. And we've seen that kind of from this kind of use case here, where when I applied f on g here, it basically gave me this new function. And likewise, when I did g on f there, it gave me some kind of another new function there. Okay, so what I have here is this very abstract, or this idea that if I somehow have this operator defined that represents function composition, I can just basically perform function composition on the fly by just simply calling this this function composition binary operator on two different functions, and as long as assuming that these two functions obey this functional type here. Now, what's important here is, at least from a very high level, is that what I'm assuming here is that if g is acting as my inner function here, the value that g gives you back, is of some value of type a, and the same value of type a should be the input for my function f there. Okay, so this is kind of the implicit constraint that is implied when using function composition. Okay, so in F sharp, there are two kinds of, there is just something called a forward function composition operator. So let's say if I have let h equal to, and this is the forward function composition operator. So this is the greater sign followed by the greater sign there. And if I were to get the functional type for this, the functional type for this is basically, it tells me that it takes in a function that goes from a to a b, it then takes in a second function, goes from a b to a c, and then gives you back this third function, goes from an a to a c there. looking at this functional type here, at least there's one interesting thing that we can note here is that let's just call this function f here. Let's just call this as a function f, and let's call this as some kind of function g. And the question is, can I, just by looking at this functional type here, can I infer whether this is acting on f of g of some value x there? Is this what's being interpreted here? Or is it the other way where I have g of f of x here? Like what exactly is this thing doing there? So to really to understand this is I can see that my function f goes from an a to a b there, right? And g goes from a b to a c. So whatever is this output of my function f is getting fed into my input, into my function g there. Okay, and that can only happen if this function f is acting in this case as my inner function here. So what I really have is, in this case, what this really implies here is this is f of x. F consumes some kind of a value of type prime a. It gives you back some value of type prime b, and that prime b is fed as an input to my function g. Okay, so this is basically what's getting implied there. So f is acting, in this case f, the first parameter into the forward operator is acting as my inner function, and the second parameter over here is acting as my outer function. Given this intuition, given this idea now that the first parameter is my inner function and the second parameter, my second function, is acting as my outer function, I can go back to my definition there and I can say, okay, let's just define, let f of x equals to x squared, and let's define let g of y equals to 2y. And I'm going to say let this new function h be basically f on g, and I'm going to say let the value be equal to h of 2. Okay, so again, as a recap, what we've understood here is that the first parameter, if I call the first parameter as a set f, and if I call the second parameter here as a g, f is acting as an inner parameter. So this is acting as an inner parameter, and this g over here is acting as an outer parameter. Okay, so what is this value going to be equal to? So if f is acting as an inner parameter and I'm making x equal to 2, f of 2 is going to be equal to 4, and then finally g of f of 2, this is going to be equal to, well, in this case, if f of 2 is 4 times 2 is 8, so this is going to give you back a value of 8. So I expect this value to be equal to 8 there. So let's just try this, and if I were to run this, I can see that the value is actually equal to 8. If I were to flip them around, if I were to say this is f there, and let's say this is g there, then I'm going to get 16 there, right? Because now what has happened is that f over here is acting as my outer function, g is acting as my inner function, and what it really means is that I have here f of g of x. And again, assuming that x is 2 there, g of 2 is going to be equal to 2 times 2 is 4, and f of 4 is going to be equals to 16. Okay, so I expect now value in this case to be equal to 16. Okay, so if I try this, if I run this again, I'll see that now value equals to 16. Okay, so this is basically what function composition is, and again, we kind of looked at it very quickly, and but again, the whole point of these videos is to just give you a few working examples and kind of build up this knowledge of what these what these different kinds of ideas do in functional programming, and so that you can take these ideas and build on them as you learn new material.